So here we have the function 3 raised to the power of e raised to the power of x. So we need to find the derivative of this given function with respect to x. So what we are going to do here is we are going to assume that if e raised to the power of x is equivalent to x, then we have the derivative of 3 raised to the power of x, which is 3 raised to the power of x times the natural log of 3. So we have 3 raised to the power of x. So x here is e raised to the power of x times the natural log of 3. Then we need to multiply it to the derivative of our assumption, which is e raised to the power of x. Now derivative of the exponential function is the function itself. So we have e raised to the power of x times 3 raised to the power of e raised to the power of x times natural log of 3. So this is the derivative of our given function. Let's move on to the next question. So here we have the function log of 3 to the base of x. We need to find its derivative, but before that we have to change the base of the function, the log, to the exponent. So we will apply the property that log of a to the base b is simply equals to natural log of a divided by natural log of b. So that means our given function now transforms to natural log of 3 divided by natural log of x. Or we can rewrite it as natural log of 3 multiplied to natural log of x raised to the power of -1. So now we find out the derivative of natural log of 3 multiplied to the natural log of x raised to the power of -1. Log of 3 being a constant, we can pull it out of the derivative. So we have log of 3 multiplied to the derivative of log of x raised to the power of -1. Now we will be applying the chain rule. So in order to do that, so we are going to assume that if log of x were equals to x, then log of x raised to the power of -1 becomes equivalent to x raised to the power of -1, and then we can apply the derivative using the power rule. So we have log of 3 multiplied to -1 times log of x raised to the power of -1 minus 1 multiplied to the derivative of the assumed value, which is log of x. So this is the chain rule. So we have negative log of 3 multiplied to log of x raised to the power of -2 times natural log of x. The derivative of it is 1 over x. So this gives us negative natural log of 3 divided by x times. So we can take that natural log of x raised to the power of -2 to the denominator. So that gives us natural log of x whole squared. So this is the derivative of log of 3 with a base of x. Let's move on to the next question. So here we have the function 3 raised to the power of x squared plus 2x. So let's find its derivative with respect to x by using the chain rule. So we're going to assume that x squared plus 2x is equivalent to x. So that means we will be finding the derivative of 3 raised to the power of x, which is simply 3 raised to the power of x times the natural log of x. So we should get 3 raised to the power of x. So x here is x squared plus 2x times the natural log of 3 multiplied to the derivative of our assumption, which is x squared plus 2x. So which will be equals to 3 raised to the power of x squared plus 2x times natural log of 3. Now we have derivative of x squared, which is 2x, plus derivative of 2x, that gives us 2. So this is the final answer, that is the derivative of the given function. Let's move on to the next question. So we have the function 3 raised to the power of x log x. So let's find its derivative with respect to x. So we are going to assume that x log x is equivalent to x. So that should give us 3 raised to the power of x, which is x log x, times natural log of x multiplied to the derivative of our assumption, which is x log of x. Now we'll have to find the derivative by applying the product rule. So that will be 3 raised to the power of x log x times log of x, or natural log of x. We are assuming that all the logarithm has the base of e, times, treating x as the first function, so we have x multiplied to the derivative of the second function, which is log of x, plus the second function multiplied to the derivative of x. So that gives us 3 raised to the power of x log x times log of x multiplied to x times derivative of log of x is 1 over x, plus log of x times derivative of x, which is 1, which gives us 3 raised to the power of x log x times log of x multiplied to x over 1 over x is 1, plus log of x multiplied to 1 is log of x. So this is the final answer. Let's move on to the next question. So here we have log of sine x whole square. Let's try to find its derivative with respect to x by using the chain rule. So this time we're going to consider log of sine x. Not consider, we're going to assume that this is, if it were equivalent to x, then we have to find out the derivative of x squared. So by using the power rule, we have 2 times log of sine x raised to the power of 2 minus 1 multiplied to the derivative of our assumption, which is log of sine x. This will be equals to 2 times log of sine x multiplied to derivative of the logarithmic function. Now we have log of sine x. Now this time we are going to make an assumption that if sine x were equivalent to x, then we have derivative of the logarithmic function, which is 1 over x. So x here is sine of x, so that means we again need to multiply it to the derivative of sine x. So this gives us 2 times log of sine x multiplied to 1 over sine x times derivative of the sine function is cosine of x. So cosine over sine is the cotangent function, so we have 2 times cot of x multiplied to the log of sine x. So this is the derivative of the given function by using the chain rule. Let's do another problem. So here we have the function sine of log of sine x. So let's find out the derivative with respect to x. So let's make an assumption that log of sine x is equivalent to x. So then we have to find the derivative of the sine function, which is simply cosine of x. So x is log of sine x. Then we need to multiply it to the derivative of our assumption, which is log of sine x, which is equals to cosine of log of sine x times, so derivative of log of sine x, so this can be computed by assuming if sine of x is equivalent to x, so we have derivative of log of x, which is simply 1 over x. So this will give us 1 over sine x multiplied to derivative of our assumption, which is sine of x. So we finally get cosine of log of sine x multiplied to 1 over sine x times derivative of the sine function is cosine of x. So cosine of x over sine of x is cotangent of x multiplied to cosine of log of sine x. So this is the derivative of sine of log of sine x. Let's move on to the next question. So we have the function e raised to the power tangent of 3x. So let's find out the derivative with respect to x. Now we are going to consider tangent of 3x to be equivalent to x. So that gives us e raised to the power of x, which should have given us e raised to the power of tangent of 3x. But this is an assumption, tan 3x the equivalent to x, so we are going to multiply it to the derivative of tangent of 3x. Now we're going to assume that 3 of x is equals to x, so that means we have to find the derivative of tangent of x, so that should give us secant squared x. So x here is 3 of x, but it's not, it's an assumption here, so we have to multiply it to derivative of 3x. So that gives us e raised to the power tangent of 3x times secant squared 3x. Derivative of 3x is simply 3, so we multiply it to the final answer. So this is the derivative of e raised to the power of tangent of 3x. Let's do another problem. So let us find out the derivative of e raised to the power square root of cot of x. So we are going to make an assumption that square root of cot of x is equivalent to x. So that means we'll get e raised to the power of x, and the derivative of the exponential function gives the function itself. So we should get e raised to the power square root of cot of x times the derivative of our assumption, which is square root of cot of x. The square root of cot of x can be rewritten as cot of x raised to the power half. Now we're going to make another assumption that cot of x is equivalent to x, so that we have to find out the derivative of x raised to the power of half. So that gives us half x raised to the power of negative half. So we will have e raised to the power of cot of x times, so we apply the power rule, we have half multiplied to cot of x raised to the power of half minus 1, which is negative half, times the derivative of our assumption, which is cot of x. So that gives us e raised to the power of cot of x times divided by 2. So we're taking the cot of x raised to the power of negative half to the denominator. So we have cot of x raised to the power of half times derivative of the cotangent function is negative cosec squared x. So this is the final derivative of e raised to the power of square root of cot of x. Let's move on to the next one. So here we have the function e raised to the power thrice x multiplied to cosine of 2x. So we have to find its derivative with respect to x. Now since there are two functions multiplied to each other, so let us consider e raised to the power of 3x as the first function and cosine of 2x as the second function. So we're going to first apply the product rule. So we have the first function multiplied to the derivative of the second function plus the second function, which is cosine of 2x, multiplied to the derivative of the first function. So that gives us e raised to the power of 3x times. Now we have to apply the chain rule in order to find the derivative of cosine of 2x. Now what we're going to do is we're going to assume that if 2x were equivalent to x, then we have to find the derivative of cosine of x, which would have given us negative sine 2x. But 2x is an assumption, so we multiply it to the derivative of 2x. Similarly, we have cosine of 2x times derivative of e raised to the power of 3x. So we're going to assume that this 3x is x, so that should have given us e raised to the power of x. But since it's not, so we're going to multiply it to the derivative of 3x. So we have negative e raised to the power of 3x times sine 2x, and derivative of 2x is 2, so we multiply it to it, plus cosine of 2x times e raised to the power of 3x times derivative of 3x is simply 3. Now we're going to take e raised to the power of 3x as the common factor, so that will be multiplied to. So let's start with the second term. So when you take e raised to the power of 3x as the common term, we are left with 3 cos 2x minus 2 times sine 2x. So this is the derivative of e raised to the power of 3x times cosine of 2x, which have been determined by using the product rule as well as the chain rule. So let us do another problem.